Hello everyone, to another video where I'll be explaining in details a relatively easy way to create and design a robot character, like this one. I will be creating this mech from the concept art all the way to modeling and rigging. This is more of a tutorial for design and workflow that can be applied for any character in general, specifically hard surface ones. Now first, I start blocking and testing with shapes. I'm still not sure of the proportions I want, or if I want the leg to have 2 joints or 3 joints. That's why I make sure to keep the blocking stage out of simple boxes to make it easier to edit. Now let's take a screenshot out of this simple model I made and go to Photoshop or any drawing program to try to test with details and see what might look good and what not. And I do this while having lots of references on another monitor. Drawing the concept art on top of the model is much easier, and you don't need to think about the perspective of each part while drawing. In this stage, you shouldn't be attached to your first design, as different details might work better for the body shape. And as you can see, the shape I'm drawing now is not the same one I settled on at the end. A good advice to keep your concept looking good is to maintain the same design for all body parts. For example, if you are using hard angles, keep that everywhere. If you're using arcs or somewhat organic shapes, also keep using that everywhere. It's similar to coloring. You wouldn't paint every part a different color, unless that serves your concept and the story of the character. Maybe you want the character to be made out of recycled pieces in a post-apocalyptic environment, or maybe it's a robot made in the backyard of a super genius kid. But in my case, I'm making some kind of a sci-fi war machine that fits in a short film I'm making. It's easy to draw when you have references on the side and a perspective of your model in the background. You don't have to be a master at it, as long as you understand what you are drawing and you can model it. Then that's good enough. I made a copy of the reference in the background to draw the leg on the side to not overlap with the other parts. And I start thinking about the joints and how they will operate, because I don't want to have floating limbs for the character. I'm not going to make it complicated for now, but if you're interested in that, make sure to subscribe, and I'm definitely gonna make more stuff in the future. Now after finishing the concept art, I was still not fully satisfied with the shape. So I tried a different approach for the body shape, and I had to edit the leg and some other body parts to match with the design. And as you can see, in the end, the result of the design language was very obvious and readable. Now we jump back to modeling. Even though we will add to the concept art later on, and I will explain that later, but for now, I'll add a sphere and start modeling the body shape, and change the visibility of the blocking stage to wire only. I'm using also the solidify modifier to create some sort of an armor plate look. For the shoulder part, I'm adding a cylinder and deleting the unnecessary surfaces, just like I did for the body. I'm trying to close the gaps and continue modeling simply by extruding some edges. While doing the modeling stage, I have the concept art that I made on another monitor alongside some references. To create an arc on this corner, I do an inset and then reshape it with additional loop to get an arc shape. I add now another sphere and delete the part that I don't need. Most of the modeling so far is fairly simple. I'm just adding loop cuts and moving them to create the desired shapes. Then delete or extrude them and make sure not to have triangles in undesired places. For the arm, I start with a cylinder to get the perfect arc shape, as it's easier to then just extrude it to finish the rest. While modeling, I come across an area where I need to use the bevel. But keep in mind that this will create n-gons, or faces with more than 4 vertices, so I have to connect the new vertices to get all quads again. An easy way to get a circle in the middle of a surface is by having enough polygons, then using the loop tool add-ons to get a perfect circle. The arm now is not vertical or horizontal, so if I need to, I can copy instance to the side and make it vertical, which can be easier sometimes, and because it's an instance, all edits will be applied on the original model too. Here, I'm using a cylinder only as a reference for the forearm shape that I already started with. And again, at the bottom here, I add more cuts to create circle with the loop tool add-on. If you are dealing with an n-gon flat surface, you can also deal with it with insetting it. I create a box to start modeling the hand and then perform a boolean on it. But just like beveling, that left me with n-gons, and I have to fix them with connecting vertices with more loops. I also try to get rid of any unnecessary polygons by fixing the topology and transferring 3 polygons to 1 like here on the hand. The fingers are simple, just some cylinders for the first finger, then basically copy and change the length of each. Now, let's think a little bit about the joints. The shoulder joint is especially a complicated one, because it needs to rotate on two axes, unlike the knee or the elbow. An easy approach for the shoulder is just to make a sphere that can rotate easily in all directions. But that's a bit cheap to do every time, so I'm gonna do something different here. But for the knee and elbow, and most joints, it's very simple, we already modeled it, because it only rotates on one axis. I might also add a piston to the gun to make it extend forward. I'll probably explain and test with more complicated rigs in the future, because I tried it once for this leg and it was so satisfying at the end. Now I'll continue working on the concept art, while keeping sure it's not overly detailed and it's actually readable. Working on details gradually and not committing to something from the start is a very realistic workflow that also lets you know what works and what doesn't. I want the shoulder to have two joints that each rotate on a different axis, but they cooperate to work together as a shoulder joint that rotates on two axes. Now after finishing working on the concept art, I go back to modeling. Mainly I want to finish with everything, having thickness and being enough subdivided to look smooth. To get a sharper edge, I add edge loops on both sides of the edge. But in some areas, a loop all around the object might cause more problems than solving it. So I use edge crease by pressing Shift E, but this doesn't give as good as a result as adding edge loops because the edge will deal with less polygons. In this corner, there was obvious stretching because of the loops were going in one way. So I changed the topology here to be a ring instead of a grid. I hope it's easy to understand the difference between the two. Comment if you find any of these modeling methods hard to understand, so maybe I can make a modeling tutorial in the future for this specific topic. For some areas like this cylinder, I know that I want a support loop on every hard edge, so I just add a bevel modifier before the subdivision one. On the shoulder piece, I use edge crease more than adding edge loops, because adding edge loops on a curved surface will obviously ruin the curvature. Now I'm modeling the joint for the shoulder. I'm making it as close to the reference as possible. I changed some things to make it actually rotate without intersecting with itself, and it looked cool in the end overall. Now I start the rigging process. I start with the pelvis and go up to create the spine. Then I add bones to the limbs, making sure that the start of each bone is at the center of rotation for each rotating part. Now I'm adding a bone to the hand and setting it to IK. The IK bone must be disconnected and unparented to anything first. Then go to pose mode, select it, select the bone before it and press Shift I and select to active bone. And that's how you set an IK bone. Okay, now the important stuff. We have to go along every bone in the IK chain and lock the axis that we don't want the bone to rotate around. This only applies for robotic rigs. If it's an organic character, you don't need this step, but in a robotic character, it will look weird while moving if you skip this step. An easy way to know which axis to lock is to first show axis in the viewport from the viewport display. Now I'm adding an IK also to the gun, because at one point I want one bone to control both the hand and the gun when the character holds the gun. I divided the bone in the gun at the middle so I can have a bone later to act as a piston. I will lock rotation to all axes but allow stretching, and that will make it act as a piston. So far I can't tell where my problems are, so I will start parenting the mesh to the bone and start moving the rig to see where it breaks. I select a part and then the rig, go to pose mode, and from there select the bone that I wanted to be parented to, press Ctrl P and bone. I do this for all parts. After finishing the edits for the arm, it looks really satisfying when it moves, and that's why I like mechanical rigs. Now I'm trying to make the robot hold the gun, but I don't want to keep selecting both bones to move it, so I add a bone and parent both IKs to it. I also added a copy location to the hand so it snaps to the gun handle, trying to get a tighter grip on it. It's still not perfect and I'll try to improve it in the future, but for my current rigging knowledge, I'm very happy with it. I complete parenting the body to the armature and I do the same thing to the leg. I also play around with the stiffness to specify which bones are affected more by the IK chain. Sometimes, if a certain bone bends too much, the whole limb will look weak, so I try to limit it as I think looks better visually. After I think that everything is working okay, I copy all limbs on one side and scale it with the value of -1 on the x-axis to mirror it. And then I parent everything. And now test the rig to see if it works correctly. And do a simple quick animation. And yeah, that's it for today. If you have any questions, just let me know. And I'll probably do shorter, real-time videos to explain the principles of hard surface modeling and rigging. And let me know if you're interested in watching a material video for this model. See ya!